Hello and welcome to the webinar, and today we're doing an introduction to Couchbase for caching and NoSQL, and I'm joined today by Brad Wood, who's the CodeBox Platform Evangelist at Otis Solutions, and my name is Michael Smith and I'm the CEO of TerraTech, and we're going to be looking today at how you can use Couchbase to improve the reliability of your apps, have better uptime, and to distribute your database out across the world, and also to be able to store documents more effectively than you can in a traditional relational database. So I don't see Brad here, so I'm going to start with a question for everyone, which is I'm curious what your NoSQL experience is. So go ahead and just fill out the poll and just say whether you have no clue, you've read a bit about Couchbase or NoSQL, used it before, or maybe you're a NoSQL ninja. And let's go ahead and close the poll in 3, 2, 1. And have a look at the results on that. And looks like most people have read a bit about NoSQL. Some people are total beginners, and a few people have used it before. So that is great. We just did the first poll, Brad, and
yes, I was watching.
Excellent. And so most people know a bit about Couchbase, and some people are total beginners, and a few have used it before. So hopefully that'll
Well, that's
help.
excellent.
Great.
Yeah, that's excellent. A lot of my stuff is geared towards kind of introductory, so that should be swell.
Great. So I've handed over the screen to you.
Okay. Can you see me?
I can see you. So who are you, Brad? I didn't give them your bio.
Oh, that's fine. I can show them right here. I am a Cold Fusion architect. I've been using Cold Fusion quite some time. I think I started in version 4.5 or so back when I was in college. A bit of a geek. I love Android quite a bit. I do blog, of course, when I can at codersrevolution.com. A lot of my spare time, I'm the CodeBox Platform Evangelist, so you see me blogging and tweeting a lot about that. I'm a musician, a shade tree mechanic. I've been married for 11 years. In fact, I had an old slide when I started this and it said 10 years, and my wife was sure to correct me. It has been 11 now, 11 wonderful years, and I have 3 beautiful daughters as well. So I work with Otis Solutions. They're the creators of the CodeBox platform and the ContentBox CMS. If you guys need any help with either of those platforms, you need consulting or server tuning, custom development, any training or mentoring, Otis Solution does all of that. So you can check out their site at ortissolutions.com. And of course, the Couchbase SDK I'm talking about was developed by Otis Solutions. All right, so we just got done with the poll. Let's kind of jump in and let's talk about Couchbase for a minute in NoSQL. So what is Couchbase? Couchbase is a distributed and scalable NoSQL database. And there's sort of several different flavors of NoSQL floating around. There's document databases, there's graph databases, there's several different things. So Couchbase specifically falls in kind of the category of supporting key value stores as well as document-oriented use. So whenever we say document-oriented uses, what we basically mean is JSON documents. But since it also is just a sort of key value store, it works really great for caching. It is also open source under the Apache 2.0 public license, and it has both enterprise and community editions. So like a lot of really popular open source software out there, kind of like MySQL or even Red Hat Linux, you've got the free community version anybody can use, and then you have kind of the paid enterprise version if you need to have 24-hour support and service tickets and things like that. So the main features of Couchbase are that it's super fast. All the operations are inherently asynchronous. So when I've done performance kind of measuring of Couchbase, I basically had to measure individual operations in microseconds because it was so fast. Everything is stored and pulled right out of RAM if possible, even though it's persisted to the hard disk. So it's a very quick, which makes it exceptional for caching as well as for a database. It also scales horizontally, which is a very big important thing for me. What scaling horizontally means is opposed obviously to scaling vertically. So when you scale a server vertically, think of your typical relational database like SQL Server. You just got one server, so you add more RAM, you add more cores, you add more hard drives, but you're just building up a single server. When you say something scales horizontally, it means you add multiple servers all clustered together that each takes just a percentage of the workload. And that's a really big thing for me with Couchbase. If you're looking at a lot of performance and a lot of scale, you want to be able to scale out instead of up. And that's, in my opinion, one of the issues with some of the solutions such as Memcached is even though you can add multiple servers in, each server still has to store all the documents on itself. So when you have millions of documents, you're still storing them on all the servers. On the flip side, Couchbase evenly divides those documents out, which is what I have here, the auto document sharding. Without you having to do anything, it evenly distributes them across all the nodes. So the more servers you add into your Couchbase cluster, the better performance you get because the less amount of work each individual server is having to do. It also has automatic replication. So if you want to worry about, if a server gets unplugged, what happens to the documents on those? Well, you can have replica copies of all your documents on an additional up to 3 servers. It's up to you. So you can lose a server right out of the cluster, but you still have all your data. And of course, if a node goes down, you can have your cluster automatically fail it over. So it just activates the replica copies on the other servers, and you don't even have to do anything. It just happens automatically. So it's really nice. Online topology changes. Unlike a lot of other solutions, you can add and remove servers from the cluster live at runtime. So if you're having a lot of load on your site, or maybe a server went down, you need to be able to put 2 or 3 servers in to compensate. You don't have to take your database offline. You don't have to take your web application offline. You can just add those servers in, click a button, it'll automatically redistribute all the documents, and it's very nice. The nice web admin is something I really like. Of course, Couchbase has a CLI, a command line interface, so you can script and automate anything. It also has a REST API, which most of the individual language SDKs sort of wrap around. But sometimes at the end of the day, just to go and administer my buckets, I really like the really nice web admin, and we'll see that in a bit. And of course, it's built on a flexible JSON document model. So there's lots of companies using Couchbase out there. This is a little diagram I lifted off of Couchbase's site. They've even got Adobe on there. I'm kind of curious to see internally what Adobe's doing with Couchbase. I know that Orbitz is a really big company. They have like 50, servers in their clusters. Really cool. So there's a lot of production scale that Couchbase is handling right now, which I think sort of speaks well for it and what it can handle. So sort of the 4 core principles that Couchbase talks about from their product here: the easy scalability, like I talked about, growing the cluster without needing to change your application or changing code. Always on, 24 hours a day, 365 days a year. I always want to put 365.25. You got to count for leap year. Maybe I'm a bit OCD though. But it's true though. With a properly configured cluster, you don't ever really need to have downtime. And they even support cross-data center replication, which I won't show today at all, but it's a really cool feature. If you need to do just mega scale, you can have multiple Couchbase clusters, complete standalone clusters in different data centers across the world, replicating with each other, and it's all configurable through the web interface. It's very slick. Of course, very high performance and very high throughput. And then, of course, we'll talk a lot about our JSON document model and how that's a lot more flexible and agile than working with fixed schemas. So, Michael, let's do another poll here.
So what would you use Couchbase for? Is it just to play? Are you going to do caching, or are you interested in the JSON document stores? So we'll go ahead and close the poll in 3, 2, 1, and closing. And let's see what people want to use it for. Well, it looks like JSON is the most important reason, and then caching is the second one, though there are some people who'd like to just play around with it and see what it's for. So there you go.
Well, that's excellent. Very good. Well, then let's talk about JSON. But before we talk about JSON, let's take a quick look at what our traditional data model looks like. The databases that we've been used to using since probably the 1970s, they're table-based, so they're very structured. the amount of columns in each table and the data types. So we might have something that would look like what I have here on my slide, a user table, an address table. They're also typically highly denormalized. You separate out your different entities into different tables. So we have a user in one table, an address in a different table. And our user is only capable of storing 5 pieces of data, and each data has a very specific data type. It's an integer. It's a character of only 100 characters. It's a date, right? And one of the worst hacks I've seen so many times are companies that need to store additional data in an existing data structure, but they don't want to take the time to have to make the database changes to allow that. So they start kind of sticking extra information along in the last name column, or in the address to line, because nobody uses that. And it really kind of makes a mess of your data structure, because you're confined and you don't want to take the time to re-architect that. So with a sort of document model with JSON, everything's just stored as a string, which is represented as, in Cold Fusion we'd call it a struct literal, but basically this comes from how JavaScript object would be defined. So here I have the same data, and a couple things you'll notice is my address, I have this as a nested array inside of my main document. So one of the sort of design patterns that people follow with document stores, they kind of denormalize their data and they combine it together. There's a scalability and performance issues that happen when you have a very denormalized database due to the joins, and it gets exponentially worse with the larger data set that you have. And so with JSON, what people do is they basically denormalize their data down and they combine related entities together, which may cause some duplication, but it's a trade-off for the performance and scalability you can get with this model. You're trading off some complexity of your application to keep all that data in sync. You'll also notice I've added in a catchphrase property here for Mickey Mouse, which is hot diggity dog. I can just add it in. I don't need to change the schema of the database. I don't need to push database changes or modify views or store procedures. If I want to place a new value into my JSON store and start using it, I just make my application start doing it, and I'm done. Right? And so if a view or someone tries to access my document with the catchphrase, it'll just come back as null if it doesn't exist. It just always fails gracefully. So it can be very convenient. Think of the last time on a Friday afternoon your boss came in and needed you to add something into your application that was going to take a new database column, and you're like, oh, I got to push all the database changes. This is one of the benefits you can get from JSON, is everything's flexible. It can be whatever you want. And I should also note here, each document in your Couchbase bucket actually doesn't even have to have the same schema. We could store multiple different types of users that have completely different types of properties, and as long as our application is aware of what properties to expect when, Couchbase doesn't care, and neither would any other NoSQL server for that matter. It's just there to store a string and return it whenever you need. So no downtime for schema changes. Records can have different structures, no fixed schema. And of course, it's agile. You can do rapid application development, nice and fast. Let's talk real quick about the asynchronous operations. And this here is all specific to how Couchbase works. So the app server up top, the little rack-mounted server, that's your Cold Fusion server, right? And inside our big gray box is a single Couchbase server node. You'll notice the red lines up and down to our app server come and go from the RAM primarily. So the first location when you store a document, it shoots it straight off into RAM. And I should even note that the act of sending the request off to the Couchbase server itself is actually even asynchronous. But once it's stored in RAM, which is the first place, everything internally is built on message queues. So we have a disk queue and a replication queue, and each of these are internal message queues inside of Couchbase. And so it'll get persisted to disk eventually. Just whenever it gets a chance, it'll write it to the hard drive. Your application doesn't need to wait. Now, if your application wants to wait until it's been written to the hard drive, you can do that, but by default, it won't wait. And then we also have a replication queue, which is just an internal message queue that when it gets a chance, it'll replicate that document out to whatever other nodes in your cluster are storing backup copies of it. If your application wants to wait for the replication to happen, you can. It'll be slower. You can wait, but by default, you're not going to wait. You just dump it into RAM and you can go. And of course, when you're retrieving objects, if they're stored in RAM, you don't need to wait for disk access as well. So obviously, an ideal cluster would be configured to have enough RAM to contain your entire data set within it. which might sound like a lot of RAM, but imagine if you have 4 or 5 Couchbase servers and each of them have maybe 5 gigs of RAM apiece. You're talking 20 to 25 gigs of RAM easily right there. So very fast, and everything can operate out of RAM by default. So your cluster here, this would be a simple server cluster that would have 3 Couchbase servers, and then we have 2 application servers, which for our examples would be different, Cold Fusion servers. And so, like I talked about earlier, your documents are distributed evenly across the servers, and this happens automatically for you. You don't need to do any manual sharding. Your application doesn't even have to know or care about it. In fact, your application doesn't even know how many servers are in the cluster. It's all irrelevant. That's all abstracted away from you. So, our application servers 1 and 2 are both accessing their document number 5. They're going to go to the same server from that. The document 5 is active on server 1. Do you see the little green dotted line? Shows that we have a backup replica copy of document 5 over on server 3. So if server 1 goes offline, completely disappears off the face of the planet, that can be automatically failed over. The document 5 over on server 3 will be promoted to be active on that server, and then our Cold Fusion servers will just automatically know to start getting document 5 from server 3 now. And at a later date, when you fix whatever's wrong with server 1, put it back in the cluster, everything will be redistributed evenly again. It's very cool how it works. I've played a lot with it, and it's pretty slick. So, of course, our client libraries, provide a very simple interface. You're just doing gets and sets, so you don't have to worry about any of this stuff going on behind the scenes. And there's basically sort of a map that each server keeps track of that says this document is on this server, so that way they know where to go and get them. So let's do another poll, Michael.
All right. So what are the things you're looking to get from NoSQL is the next poll. And here are the different options. Maybe it's agile rapid development, massive scale, performance, 100% uptime, or perhaps it's just something cool to wow your boss. So go ahead and check all that apply there, and we'll go ahead and close the poll in 3, 2, 1, and closing, and let's see what's the thing. It looks like performance is the most important thing there, followed by scaling and agile development, and I missed the uptime. Actually was the one after performance because it's in such a light color. So performance and uptime.
Well, that's excellent. Okay.
So
very good.
Yeah, is that your experience as well, or that most people are into that kind of thing, performance?
Yeah, and to be honest, Michael, some of the customers that we've helped get onto Couchbase through my work at Ortus, we're actually working to be resellers of Couchbase, and so we've helped several large customers. And one of their big things was they needed to have tons of traffic on their site, and they needed it to never go down. They had a usage cycle that would be overnight. They catered towards college students, which would be up really late at night doing homework, and so they couldn't have downtimes. And so Couchbase was a really good fit for them because they could manage their servers, and they never had to go offline. And of course, it could handle their scale. So I'd say that's a very common use case, Michael.
Excellent.
All right, well, let's transition into Couchbase and CFML. So we've talked a lot about Couchbase. How the heck do we use this in Cold Fusion, right? And of course, I purposely can be a bit generic with CFML since we do work with both Rilo and Cold Fusion. So one of the first ways you can use Couchbase with CFML, I won't demo this, but I'll show it on a slide, is through the ORM integration. Both Rilo and Adobe Cold Fusion have Hibernate under the covers for ORM. And there's a open source library out there on GitHub, which is a cache provider for Hibernate, because Hibernate has sort of a pluggable architecture for caching, for the second level caching, for memcached. And the great thing about Couchbase is it can be a drop-in replacement for memcached. It supports the same over-the-wire protocols on the same port, and the client never even knows it's not actually talking to memcached, but you actually get the benefit of true horizontal scaling. And disk persistence. It's not just RAM. You can reboot your servers in the cluster and you still have your documents. So that's fairly easy to set up. There's a blog entry out there on the Ortus Solutions blog that details how to configure that. That's one of the first ways you can interact through Couchbase. One of the second projects we did as we dove into Couchbase was the Cachebox provider. Now, Cachebox is part of the ColdBox platform, but I want to be very clear in saying that it's also a standalone library. So you can use Cachebox with Framework 1, with Fusebox, with your old legacy spaghetti code application. Very small library you can drop in. And we already have providers for concurrent soft reference stores, cache, disk cache, JDBC cache. So we've also gone and written an open source provider that lets you connect Cachebox up to a Couchbase cluster. Which is very handy. So you can use it for caching views, for HTML, anything you can serialize. I won't demo that either, but I just wanted to throw that slide out there. This is also open source, and you can use that. We also additionally have a blog entry as part of our Ortus blog series on Couchbase that shows how to use that. So the third way that we can tie Couchbase into ColdFusion, and I will be doing some demos for this, is with our Couchbase Rilo extension that we wrote for Ortus. Now this is a commercial product, and it has a native Java integration with Rilo. So this is an extension for Rilo that we wrote in Java, and it sort of ties in to the back end of Java, and it registers a new cache type of Couchbase. And what this means is you can store your query cache automatically in your Couchbase cluster. You can store your template cache automatically in Couchbase, your function cache. If you haven't heard of function cache, it's a really cool thing that Rilo does that Adobe doesn't do yet. You can add kind of the cache within parameters like you do on queries, but you do it in a function, and the results of the function are cached. Very slick. Also, even just the built-in cache get and cache put functions in Rilo can be repointed at Couchbase. And what's great about this is you don't need to rewrite any of your application code. You just do this from the administrator, and boom, behind the scenes, everything's pointed to Couchbase. And then one of the coolest things, I think, which also you can't do this in Adobe ColdFusion yet, but Rilo supported it for a while, is your entire session and client scopes can be repointed to Couchbase. So everything in your session scope is serialized up at the end of the request and stored in Couchbase. And so if you have a large cluster of ColdFusion servers, you want to do round-robin load balancing so people hit a different server every time, you might be thinking, well, we can't use the session scope. Well, guess what? You can. You don't need to rewrite your application for that. All you need to do is point your session scope over to a Couchbase cluster, and your Couchbase cluster can scale for as many users as you have. You don't need to worry about using RAM in the heap to store all those sessions. So it's very powerful, and I'll show real quickly how to set that up when we get to our demos. And so finally, kind of our star child here is the CF Couchbase SDK. So this is what I'll spend the most time demoing. This is, unlike the Rilo extension, this works on both Adobe ColdFusion 9 and up, as well as Rilo. And this is an open source library. Again, this isn't tied to ColdBox in any way. This is generic. You can drop this into any framework or no framework if you'd like. This has automatic JSON marshalling, so you can pass in complex structures, arrays, things like that. Automatically is turned into JSON for you. Obviously, you can store and retrieve documents from the cluster very easily. You can also create views, and then you can query those views against your Couchbase cluster. You can do that all programmatically, which is really nice. I'll show that. It also supports, the map and reduce functionality that's built into Couchbase, which is very handy. And I really like what we did serialized in CFCs. You can just pass a CFC instance into the SDK and say, here, store this. And it'll go ahead and extract the properties out of the CFC, turn that into JSON and store it. And if you simply set auto-inflate equal to true on your CFC, when you pull it back out, it'll actually recreate the CFC for you, put the data back into it, and it's completely seamless. You pass CFCs in, you get CFCs out. So that's really cool, and I'll have a link to a sample app that shows how to do that later. Of course, it supports all the async operations. Our CFML SDK is wrapped around the Java SDK, but we really made it nice and easy to use with the ColdFusion language. We've introduced things like closures to be able to filter and transform the results. We've simplified it for CFML, whereas the Java SDK is very verbose, a lot of overloaded methods. But you can still have the power of the asynchronous operations. You can get the features back. So it's very simple and easy to use. So before we get to our demos, let's talk about the platforms people are using, Michael.
Yeah, so what programming languages are you using on your server? All apply would be good to put in. And And I'm assuming Couchbase works with many different languages. Is that true, Brad, or is it just Cold Fusion?
There are official SDKs for Java, Ruby, Node, Go, I think even Erlang. The Couchbase company has a ton of official, and they have a number of community ones. We're actually working with them to get our CFML SDK to be an official SDK as well. But so yeah, if you're playing with other languages, Couchbase crosses that divide very well.
Well, it looks like, not surprisingly, on this call, most people use Cold Fusion, but we've got a substantial number who use Java as well, and some folks using PHP. So,
okay,
that is very interesting.
Yes, I believe there is also a PHP client as well. I forgot about that one. Well, yeah, for the people using Java, that would be a very easy transition, since of course the CFML SDK gives you access to the Java client underneath the scenes that it creates. So it'd be a pretty seamless integration to jump between the two. All right, well, let's take a little bit of a look at some code. First, I'm going to show the Rilo extension, and then we'll take a quick look at how the CF Couchbase SDK works.
And I think you told me earlier that you've put all the code onto GitHub so people can...
yes, I have. I'll have that link in my final slide for sure. You guys can just check out what I'm demoing today on GitHub afterwards. Okay, let's take a quick look at a Rilo administrator. What we've done with the Rilo extension is we've created our own provider, and I don't know, some of you that don't use Rilo, you might not be as familiar. Adobe Cold Fusion doesn't have currently any sort of inbuilt mechanism for kind of drop-in packages that extend the platform. You could think of Rilo extensions as sort of like gems maybe for Ruby. Anybody can write them, they can host them, and you can kind of just drop them in. They can extend the core platform. So what we have is there's a couple default providers, which are essentially URLs where the platform can find these extensions to install. What we have is our own Order Solutions provider that hosts our Rilo extension and anything else we may build in the future. And so after you've added that provider, when you go and you look under Applications, these are a list of all the extensions here that you can install into your Rilo server. As you can see, there's extensions for all sorts of things in here. Cache, there's paid extensions from Rilo to monitor your memory usage and all sorts of things. So there's two that will show up in here. We have our commercial orders extension, and then we also have a trial here. So I've gone ahead and I've installed the trial. It's very easy to install. You just click on it, and it'll come up, and you just hit the install button. It'll ask you a couple questions, like the license key if you've purchased the commercial version. But the trial just installs quite easily. So I have the trial installed here. We can see some information about it, the version, where it's from, and that's pretty much all you need to do for it to be activated. Is just install it right here through the web admin. So once we've installed that extension, what we can do is go to our cache portion of the administrator under Services. And again, this is something unique to Rilo. You won't find this on Adobe, unfortunately. And we can define multiple caches. So the default cache in Rilo, like Adobe Cold Fusion, is cache, but you can connect to multiple external servers here. And so under the Create New Cache connection, you'll see that in the drop-down, we have a new item along with RAM cache and cache. What our extension has done is it's registered Couchbase server right here in the drop-down. And so if I want to add a new cache that connects to a Couchbase server, I can just come in here and I can point to the location of the server. Defaults to just running locally. You can specify the name of the bucket, optional password, and we have some defaults here that you can set. And of course, you can set this cache up to be default query cache, default template cache. Very easy and very straightforward to add these through the interface. So I have a couple caches I've created here already. I have one here called My Cache, which points to my default bucket. I've set that as my default object cache, so any usage of the cache put or cache get functions in this Rilo application would automatically go to my Couchbase cluster. And then I've also created a Couchbase cache called Sessions. And this points to my local Couchbase installation. And in case you're curious, Couchbase does run on just about everything, Linux, Windows, Mac. So the installer is pretty easy to go through. I just have it installed locally here. And I'm pointing to a bucket here that I have called Sessions. And if we look here, this is an example of what our Couchbase sort of web administrator looks like. You hit this on port 8091. You can see here all the buckets that I have here. Beer sample is a sample bucket that Couchbase installs optionally for you if you choose to play around. Default is sort of just the default bucket it gives you. And then here's the bucket I created called sessions. And you can kind of think of buckets as tables in a normal relational database. Except you're not going to have nearly as many buckets as you do tables. Buckets are more kind of for portions of your application. There's a lot here to the web admin, and I won't dull you guys over with getting too deep into it, but there's a lot of really cool performance statistics you can look at here. There's a whole page full of graphs to let you view, and you can get at all these statistics via the CLI as well and the REST interface, as well as through the SDK. There's methods to get these statistics. But sometimes you just want to log in and look visually, and you can see this all right in here. So let's take a look at what it takes to enable the session storage in Couchbase. I've got a little demo app set up here. In my application.cfc, the only thing you need to do in your application is once you've created that cache, sessions is the name of my choosing. You can call it whatever you want. But you just add this .session storage equals and then the name of your cache that you created in the back end. So there's the name of my cache sessions. And if you have multiple web servers, then you might want to set session cluster equal to true. And this basically just makes sure that each request may not go to the same Cold Fusion server, so it doesn't rely on what's in memory. It always goes to the server, the Couchbase servers. So with that, that's all you need to do. In my index page, I'm setting a session variable. And I'm just going to output it here just to use the session scope very simply. So if we go and view our sample application, obviously refreshing the page, nothing amazing to see, but you can see that our value is being output, so our session storage is being used. And if we go and look at our session bucket, we can see activity here. So these spikes here when I refresh the page, and you can see that it's two requests per second, or 2 operations per second were happening. Obviously, one operation to get my session value, one operation to set my session value. It's kind of fun just to sit here and mash down on the F5 key and then go look at the chart going crazy. I gotta keep up. Of course, 60 operations per second is nothing. I've seen Couchbase easily do tens of thousands of operations per second. So that's about all there is for the session replication. It really is that simple. You just install the extension, create a cache, and then set up in your application.cfc. I mean, you just use your session scope like you always do. And as you can see, it's actually storing it. And I suppose I can also show you, if we look in our sessions bucket, we can also see there will be a document here. And this is named after my session. For every session that is being stored, you'll have one document in the bucket. And this big string of gobbledygook here is basically the serialized version of everything that was in my session scope. But that's all seamless. Works very well. Let's see here. Where are we at? I think it's time for another poll.
Okay. Well, we've gone through a lot of NoSQL, so I guess the thing is, what's the biggest thing keeping you from using it? Maybe it's nothing because you're already using it, or cost, time, perhaps it's strange and scary, or perhaps it just doesn't solve any problems you currently have. So we'll go ahead and close that poll in 3, 2, 1, and let's look at the results. And seems that strange and scary is the #1 reason people are not using it. And I can understand that because it is a little weird when you first look at it. But then also the amount of time it might take to get up and running with it. And of course, cost doesn't apply because it's open source. So there you go.
All right, well, that's good to hear. Well, the good news is, our next demo here, I'll show just how easy it is to play with the CF Couchbase SDK. And like we talked about, we'll have my sample code available, and I'll also show you guys where some of the sample apps are that we have built using Couchbase. I would encourage you guys just to kind of play around with it. I'll admit it is kind of strange and scary before you get into it, but once you start to play with it, you get used to it pretty quick, and you start thinking, this isn't that bad.
And before you go into the demo, I was going to mention we're going to do a Q&A after the demo. So if you want to start putting questions in, I see Barbara's already put a question in, and we've got a few others from some other people. and just put those in the question box rather than the chat box, and we'll go through those after this demo.
All right. Thank you, Michael. So let's take a look at the CF Couchbase SDK. So the CF Couchbase SDK is open source and is made by Order Solutions. It was actually done for one of our clients, Gardley, helped sponsor that, so we're thankful to them for that. And it's free to use, it's fully documented, and of course it works on both Rilo and Adobe ColdFusion. And you can drop it in quite simply into any old application, whether or not you're using any framework at all. So let's take a look at some simple examples of what it takes to use it. In my example here, I have installed the Couchbase SDK by just dropping the CF Couchbase folder into my web root. You can either do that, or you can create a mapping. A lot of people like to store their non-web code out of the web root and use application-specific mappings. That's fine. But you can also just drop it in here, so it has all the files you need. And to use it, let's take a look at this file. All that we need to do is instantiate a new instance of our Couchbase client class. So I'm setting it into a variable called cbclient equals new cfcouchbase.couchbase client. And of course, new is just a newer syntax for create object, if that's what you're familiar with. But I really like to do this in the script. I think it looks nice and clean. So that one line of code is honestly all it takes to get a connection to a Couchbase cluster, and now we're ready to start using it. Obviously, I'm falling back on quite a few defaults here. You can pass into this constructor here an object that says, the servers you want to connect to, the buckets you want to connect to, all sorts of tons of, fine-tuning performance variables. In fact, if you want to look at them, they're all in our API docs. We can also take a look at the Couchbase config object. Everything in here is something you can configure. There's tons of nitty-gritty, junk in here. But as you can see, the default is simply a locally running server and the default bucket. And so you don't need to go crazy just to play with a really simple example. So the first operation here is just set. We have cbclient.set, and I'm passing in two things. The first thing is the ID of the document. Think of this as sort of the primary key, if you will. This is going to be unique for the bucket, and it's what I'm going to use to request this document back later on. And then my second thing that I pass in is just this sort of JSON structure, which is actually a struct literal in ColdFusion that defines my document. And so here I have Mickey Mouse. He's a male, and I have a little nested array of features right here. He's known for ears and gloves. And a little note everybody might not know about Mickey and Minnie Mouse. Watch them. When they turn their head sideways, their ears always face you, which is kind of freaky. Try it next time. When they look to the side, they'll have an ear on their forehead and an ear on the back of their head. True story.
That is pretty clever. So this is creating records in the database?
Yes, it is. And so even though I'm passing in a complex structure, an actual struct, this will be converted for me into the string representation, which looks the same, except for I think these might be quoted. And it'll be stored into Couchbase. And so I've got a handful of here. I'm going to go ahead and set it in Mickey Mouse. She's known for her ears, wearing gloves and a bow. Got Donald Duck, Goofy, Gorsh. And, of course, Pete, who I had to look on Wikipedia. He's actually a cat. I never knew that. The big Pete guy, he's kind of mean, wears gloves, he's fat. So that's all it takes here. Set 5 documents into, sorry, I'm probably scrolling way too fast. I should quit that. Set 5 documents into our cluster. And then at the bottom of this page, we can see to get a document back out, we just do cbclient.get, and I'm just going to pass in the ID. So the document with the ID of 3 was Donald Duck. And just going to dump that out to the screen and then shut down our client.
So you could have several servers doing all this at the same time. Is that right?
Web servers or Couchbase servers? Because the answer
Couchbase
to the question is yes. Yes, okay. Absolutely.
And so, in that case, how would you know what ID number to use? Because if you're using ID number 1 on your server, wouldn't someone else be using ID number 1 on their server, and you get a collision or something?
No. So the IDs are up to you. You choose what you want them to be, right? And so they need to be unique, but this is your application, right? Other random people around the world aren't using your Couchbase servers. They're your Couchbase servers that you're connecting to. So your application controls what you want the IDs to be, right?
Okay, so you just need some logic in there to make sure IDs are unique.
Sure, and in this super simple example, I just kind of manually put in 1 through 5. You can do some design patterns where you have a document that holds like the next integer, and you can call an increment command, or let's give you back the next number. That's very common. You can use a GUID if you want, just like what you might use in SQL Server.
That would be a distributed document with the next ID, so it wouldn't be necessarily up to date on your server, right?
No. So here's the thing. If you used a document in a bucket somewhere on your cluster to store the next ID, that document's only going to be active on one server. So you might have 50 Couchbase servers in your cluster, but only one of them is in charge of storing the document that has the next ID.
Okay.
And the operation to increment is atomic. So you're guaranteed consistency in that. When one thread says increment the counter and tell me what the next number is, it's guaranteed to get an atomic value back that's consistent.
Okay. And then how does that work with the failover if you have one Couchbase server that serves up the IDs?
Exactly. So if you're configuring replicas, and I'll actually show you real quick how you do that. If I go to buckets and I create a new bucket, I can create a bucket called test. I can say I want it to have 100 megs of RAM, not very much, but it's just an example. Right here under replicas, all you do is you simply say I want to enable replicas, and you can choose if you want 1, 2, or 3. So this is the number of other nodes that will store a backup copy of your documents, right? So by default, I can say store one backup copy of every document on another nodes. That's how you enable replica when you create a bucket. It's very easy. And so if the primary node goes down that's stored in the active document, when it's failed over automatically or manually, the server that has the backup, which is being kept in sync via those replication queues, it'll simply be promoted, and it will now be the active server for that document, and all the clients will automatically just repoint to there. So you only have one document and one server at a time that's active, even though you may have replicas waiting in the wings. Does that answer your question there?
It sure does. Thanks, Brad.
Yeah, no problem. So this is what the output from that page looks like. Obviously, there's no output from the set operations, but we did a get at the bottom, and we retrieved out our document with an ID of 3, which is Donald Duck, and you can see it comes back out as just a regular struct, which is exactly how we put it in, and you can deal with that data in your application as struct and arrays as well. Quick note on the creation and shutdown of the client. I kind of did these samples to be very simple and to fit on one page. Typically, you wouldn't create and shut down the client every time you used it. That would be a bit cumbersome. So the very easy way to do it is, like in a legacy application without using any framework, is just to simply create the client in your on-application start and just shut it down in your on-application end. And that way it's just always available and it's persisted there. Just store it in the application scope. So like, application client equals. Obviously, if you're using frameworks like Coalbox, there's a lot more flexible ways to do that with Wirebox and things like that. But typically, you're going to want to store the client somewhere and not recreate it. But I just wanted to kind of show it here as a really simple example. And I'll show you some sample apps that show how that works a little bit later on. So getting and setting, there's a lot of different get and set operations that I won't even get into right now because I want to keep the scary away for now until you guys get a chance to play with it. But check out the API docs for this, which I'll show at the end here. There's lots of different options you can do with getting and setting, but the most simple ones are very straightforward. So let's take a look at querying views. I don't want to get too deep into how views work in Couchbase because they can be a little freaky at times, but they're pretty powerful. And once you've created them, it really doesn't take that much code just to go ahead and execute them. I like to think of a view in Couchbase as an index on your kind of typical relational database, right? So if you have a user table and you want to, commonly select out based on last name, find people with a last name that matches something, right? Then you could create an index on last name, which sort of stores a secondary bit of information, on the hard drive that's just a list of last names all sorted. That's kind of what a view is in Couchbase. except for instead of just selecting the columns, since we're schema lists, you actually specify a JavaScript function which will be applied to every document in the bucket to build up the list of data for our index or for our view. So you can create views through the interface, through the web admin, which is very nice, but you can also have the view creation right here in your code. So I'm creating a Couchbase client again, just as before, and I'm going to call a save view method right here at the top. And it's important to note that this method, you can call it as many times as you want. It's only going to actually do it if it doesn't exist. It does a little check first. I would recommend if your application wants to use views, you could run a save view right after you create the client when the application starts up, and it'll create them if they don't exist or update them. So Couchbase has design documents, which are kind of our container for multiple views. So I created a design document called cartoons, and I've named my view list characters. These names are arbitrary, it's just what I chose. And then here we have a string representation that's a JavaScript function, and this function is called for every document in my view, and it builds up our sort of index. And like I said, I don't want to dive into that too much. I don't want it to be too confusing. There's a lot of reading you can do there. But basically, this is just going to make a list of all of our characters, and it's going to have the ID of the character and the name from the document. And so to execute that query, once we've created it, it's very simple. We just have our CB client, and we just call a query method. We tell it the name of the view we want it to go ahead and execute, and then we have some options we can pass in. So I'm going to tell it I want it to sort ascending, which is going to be based on the ID. Of course, my IDs are just 1, 2, 3, 4, 5. Kind of similar to MySQL here. Offset 1 means skip the first record. Limit 2 means stop after you've reached 2 records. And I want to go ahead and include the full JSON document in my output. So we should get 2 documents back, and it should be our second and third records since we skipped the first one. And then we'll just dump out those results and see what they look like. So here's our output from that. We have Minnie Mouse and Donald Duck are the 2 results that came back. It just comes back as a regular old array. You have the ability to deal with the native Java objects if you want to deal with, but by default the SDK is going to turn everything into nice, clean, cold fusion structures and arrays you can deal with. And so that's basically. I guess I have one more example here. I'll show you of a view. Here's another view I created, and you'll remember that each of my cartoon characters had an array of features sort of nested inside of them. This view creates a record for each feature, so I can kind of query out cartoon characters based on their features. And then I have a reduce function. _count is a shortcut that tells Couchbase we want to do a count reduce, which will just count how many objects. Think of reduce as a group by in a normal SQL query. So if you select from users and you group by last name, it's essentially kind of the same way that reduce can work. So this would be like doing a group by with a count. So we can call this a couple different ways. We can call our features view, and we can say count the number of cartoons where the key was gloves. So count all the cartoon characters that have gloves in their list of features, and then we can just output that here. And then we can also call it, and we can say don't run the reduce, so don't do the count, just give us back kind of the raw list of people, and then we can just loop over them. It's just an array. For I and results, we'll just write output each name. And if we run that, the output should make a bit more sense in the code. Number of characters wearing gloves is 4, and here's the list. Mickey, Minnie, Goofy, Pete. Those are the 4 people known for gloves. And here's kind of the raw output of what the output looked like. There's the array. So just kind of scratching the surface of what you can do there with executing views. The map and reduce stuff is really cool, but you can kind of learn that as you go. So that's basically the end of the demo. There's a ton of stuff I wanted to demo, but I made myself not go crazy just so I wouldn't flood your minds. Last little note, we have some samples that are in our regular Couchbase repository that deal with that beer brewery bucket that I talked about. There's a super simple one that's just like no objects, no frameworks, nothing. There's a version that uses objects, and then we have an MVC version that kind of shows how you do that with ColdBox. I won't go into the code at all, but you can pull this right off of GitHub. This is kind of a more larger-ish, full application that lets you, go through and interact with the entire, bucket. It's a list of breweries and beers and things. This shows the CFCs automatically being serialized and reinflated. Very cool. You can dig through that in your spare time. Here on GitHub is where we have the Couchbase SDK listed, and the samples directory is right in there. So come to GitHub and you can fork and you can star this repository as well for the SDK and play with it. And that concludes my slides and my demo. So here's some contact information before we get into the Q&A. Obviously, Couchbase.com is where you can grab the installer to install Couchbase locally and to start playing around with it. Also, you can read about the CF Couchbase SDK, their order solutions, and then, of course, all the code that I showed today is in my own little GitHub repository, CF Couchbase demo. Once you've installed Couchbase, you can just copy that stuff into your web root and you can just run it. And then, of course, the code for the CF Couchbase SDK with its sample apps are also right there on GitHub.
Great. Well, wonderful information there, Brad. So the first question we have from Barbara is, are the sessions HTTP only, or can you do secure sessions?
That is just entirely based on what Rilo does. So you can do whatever Rilo does with the sessions. How they're stored on the back end is actually is sort of irrelevant to whether or not you're using Couchbase. So you can store your sessions on a Couchbase cluster, and you still have full access to the the other options that Rilo gives you on how those work on the front end and how the cookies are set. That's all kind of abstracted away. So yeah, you can do whatever Rilo lets you do with sessions. You're not limited at all.
Okay. Great. And then another question we have, is there anyone who uses this for real-time applications?
There are. I'll be honest, off the top of my head, I don't have any names to go with that. But if you take a look at my slide deck, you look at all those pictures that were in there, all companies using Couchbase. I know that I've read some things that a bunch of those do real-time stuff. And in fact, one of the many things I didn't even talk about, Couchbase has some really cool stuff that I think is still in beta right now for mobile applications. They actually have a light version of Couchbase you can install with Android or iPhone apps, and it has an async gateway that will actually synchronize the local Couchbase, kind of like SQLite, but it's Couchbase, with a cloud-hosted one. And they did some really cool demos of games on Android phones that would synchronize automatically in real time. So there's some really cool stuff you can do, and there are definitely companies doing that. Though I apologize right now, I don't have any real specific names to answer that, but it does work very well for real-time operations. Yes.
Great. And then Mike is asking, is the cluster session storage J2EE or is it CFML?
It needs to be CFML, and here's why. When you set it to J2EE, Rilo defers to the servlet container and has, which is going to be Tomcat or WebSphere, and it has the servlet container create and store the sessions for it. And there's no hooks, in Tomcat or anything to tie into Couchbase. So if you're going to do use the Couchbase provider through Rilo, it does need to be CFML, since Rilo needs to be the one in charge of creating and retrieving the session information. It's a very good question.
Great. And then you mentioned you can add and remove nodes dynamically. Is that easy to do, or how do you do that?
Yes, it's very easy to do. You can do it, through the CLI, of course. Everything can be automated, but naturally, if you're just coming in to check things, the web console is very handy to be able to see things. The first thing is that you can configure auto failover right here under settings. When you enable auto failover, right now this server is set up such that if a node were to go down in the cluster, it would wait 30 seconds just to make sure it's not maybe just a network glitch. Because obviously, there's a number of sort of fail-safes built into Couchbase to prevent, a small network, delay just failing over every server in your cluster, as that would be bad. But if you enable auto failover and you have 3 or more clusters, then it will automatically, when it notices the server has quit responding, just pull it out and it will email you. To do it manually, I only have one server right now. This is just kind of my local one. When I play with this, I just spin up some Linux VMs in VMware VirtualBox, and I just kind of add them in. You can add a server by just simply add server. You punch in the IP address. To fail over, these options are removed right now because this is the only server in the cluster. But if we had multiple servers here, remove is sort of the nice way of doing it. It says, hey, finish up anything you're doing, get rid of all your documents, and then pull yourself out of the cluster. That's what you do for maintenance. You just hit the remove button, then it confirms. You say, yes, I want to do it, and then it goes and pulls it out. In an emergency scenario in which you just need to yank a server out, even if it doesn't, finish transferring ownership of all the replicas, you can also click the failover, which is sort of a messy version of remove. But that's all you need to do, and it'll take care of transferring all the documents to other nodes in the cluster, and then it'll kind of bow out when it's done. And then when you're done doing maintenance on that server, or, upgrading the RAM, installing Windows updates, whatever it was you were doing, you can just go back in, click Add Server, you add it back in, and when you're done adding the servers in, you just click this rebalance button, and then it will redistribute all the documents evenly across the current set of nodes. But that all pretty much just kind of happens. You just click these buttons, and it goes behind the scenes, and it does it. So it's very nice.
And what about if the server just dies? I know you've probably, you don't have that happen with your servers, but I have seen servers just die on occasion.
I only use servers that never die, Michael.
In which case you're not clicking on any buttons to shut it down gracefully. Does it still deal with that scenario?
Yes, it'll still deal with that. Now you can disable the auto failover if you want to manually deal with it. Couchbase has a whole array of notifications you can have it send you. Let me look here under settings, alerts. So you can have it emailing you when a node is auto failed over, if an IP address gets changed, if the disk space reaches 90% of capacity, if the bucket memory on a node is too high. There's a whole list of checkboxes you can tell your cluster, hey, let me know if this happens, right? Oh yeah, sure. I can pop my screen back up.
Yeah, I figured it might help people to actually. I assumed you were looking at some amazing settings you can set.
Yeah, let me just show you how I got here. Inside the web administrator, I simply click on settings, and then there's several tabs of settings here. Auto failover is where you can configure that, and I'm on the alerts tab right now. So I've on my little local server, I've set up a an SMTP server, and you can just check the box here. And so it can let you know when a node has gone down, and you can go in and check it and manually take it out. Or if you have the auto failover enabled, which is a setting right over here in the auto failover tab, just a checkbox on or off, then it'll automatically pull that node out without you even having to do anything, which is great on a production server with a number of clusters, and you want to make sure your server keeps operating even at 2 a.m. in the morning, when a node went down. It'll automatically just pull it out for you. And then what happens is, assuming you've configured replicas, Couchbase will automatically promote all those documents that were replicated elsewhere to be active on a different server, and it'll just on the fly, rearrange the map, and all your clients they'll just keep getting the documents like they always did. They'll never even know what happened, but now they'll just be pointing to a new server, and the old server just won't even be in the mix anymore.
Great.
So, yeah, I really love Couchbase. I really think has kind of nailed just about everything you could think of when it comes to failing over and replicating. They did a really good job at it.
Okay, so we've got a few more questions here. One is, why is it called Couchbase?
Why is it called Couchbase? It's actually an interesting story, and I don't have it all memorized. I'd read through it. The history of Couchbase is interesting. Before Couchbase, I believe it was called Membase, and they got the couch from CouchDB. So CouchDB is an open source document store, JSON, NoSQL database, and Couchbase is sort of forked off of that. So inside of Couchbase is the remnants of what used to be CouchDB, but CouchDB doesn't have the Memcached interoperability. It doesn't have the caching layers. I don't think it has all the functionality for failover and stuff. It was just like the basic JSON document things, and that's what they kind of built it on. And I think when they were calling it Membase, they were kind of borrowing from the Memcached because they borrowed a lot from the Memcached protocols to be interoperable with that. I'll have to see if I can find it. Somewhere I actually saw a nice little timeline one of the Couchbase evangelists had made that sort of showed how Couchbase got to where it is now. Honestly, I'm not sure where the base part of it came from, other than they brought that along from Membase. But yeah, so the couch basically comes from the CouchDB that's part of it.
And what does the couch refer to? Is it?
Honestly, I'm not sure how CouchDB got its name. It may have been implying that it's so easy to use you can sit on the couch while you do it.
There you go.
I'd have to go Google.
Luis says sit and relax. That's why.
There we go. Sit and relax. Probably. Yeah. I think that was even their motto. I think that's where they get that from. But
so we've got two more questions, then we need to wrap up.
Absolutely.
First one is a short question. Do you miss SQL?
Try and miss SQL. Well, it's an interesting thing that you asked that. First of all, I haven't left SQL because NoSQL doesn't solve every problem, right? And I don't think that anybody should run out and rewrite their entire relational database to use NoSQL. There's a lot of, and I could talk for a whole other hour on this, but I won't. There's a lot of trade-offs. Everything's a trade-off. There's what's called the CAP theorem, and I almost put it in a slide, but I didn't. And it basically says that any distributed system can't always guarantee CA&P, which is consistency, availability, and partitioning. And I won't even talk about that. Check it out on the Wikipedia page. Essentially, you're always trading off one thing for another. And there's certain things that NoSQL distributed solutions can give you, like performance and scalability and partitioning, that you can't get with a relational database. But it's at the cost of sometimes consistency, as well as atomicity, atomic operations. By default, it's possible that you could set a document into Couchbase, turn around and get it, and it might not be there yet. That can happen. Or if you have an accounting application that is deducting dollar amounts from a checking account, and you need to be able to do multiple operations and still have the total match up at the end, Couchbase may not be, or just NoSQL in general, may not be the best application for that because it doesn't have concepts of transactions natively, right? So you have to ask, which parts of my application can use this for. An excellent usage for, a NoSQL bucket for you to play around with would be logging. If you want to log errors or log things from your application, and you just want to be able to just dump log messages off in a place where they just sit and you can run reporting on them later on, that would be an excellent use for Couchbase. I would say most people that use NoSQL use it alongside a relational database. So now the second half of my answer to that is there's some really, really cool things going on with Couchbase that I kind of wanted to do a demo, but I didn't. But you can go check it out. It's called Nickel, N1QL, and they pronounce it Nickel. It's kind of a combination of non-first normal form and SQL. This is in beta right now. It's in developer preview, and I'm hoping this will be out in a few months. And what this is a way that will let you query your Couchbase buckets actually using SQL. So if you have a bucket called user, you'd actually type select star from user where last name equals Wood, and you would get back the document for Brad Wood. It's really, really cool, and they're trying to bridge the gap here so people coming from a relational database can actually use what's natural to them, which is structured query language, but use it on documents. And there's a demo here you can download. It's actually pretty easy. You just download it, unzip it, and you can pop up a little web page and play with it. And that's going to be part of Couchbase soon, which is kind of funny because it's NoSQL, but they're putting the SQL back in NoSQL. So I think some people are starting to use the phrase new SQL, like NEW. But yeah, once you play around the Couchbase, you can have a look up there, N1QL, pronounced nickel, and it's actually a way you can use SQL against NoSQL. So you don't have to even give up SQL.
Oh, great. Well, the final question from Seth, he's asking, does a client connect to a specific node or the cluster? And if that node the client's connected to goes down, how does it know where to even fail over to?
That's a good question. So in general, the clients connect to whatever node they need to based on what document they're requesting. So each client, and by client I mean the Java client in memory that or the Cold Fusion client, they keep a sort of in-memory map that says document 1 is on node 1, document 2 is on node 7, right? And so when you go to request a node, I want, node set, or I want, go to request a document. I want document 17. The clients know which server, because there's sort of a predictable hashing algorithm that's used behind the scenes. They know what server that document's going to be on, or what node, and they just go straight directly to that server and they say, give me that document. Now, how does it know when that node goes down? Couchbase uses a ton of different ports, and so there's communication ports between nodes and between the nodes and the clients that keep all the clients updated. So, I mean, you could have 20 web servers all with, their own Java clients out there connecting, and if a server goes down, the nodes communicate between themselves. They figure out, which node is now going to be the primary host for document 17, and then they push that information out in real time to all the connected clients, and they say, hey, newsflash, this node just disappeared. Anytime you want document 17, now you need to go to this node instead. And the next time your application asks for it, it just goes to the new node, and it's all seamless. So it's basically how it does that, is it just keeps in constant communication on kind of some backdoor ports that it keeps open, and it just notifies all the other clients and all the other nodes of any changes that happen, and that's how they all keep in sync.
Great. Well, it's a really clever solution. Thanks for the detailed info, Brad. And we'll be sending out the slides and the recording within a few days, and I already put the link to the GitHub repository of the code samples in the chat window, if you didn't notice that earlier, and I'll send that out by email as well. So we'll be meeting again in a month's time on the 13th of May, and thanks so much, everyone, for attending.
Thank you, Michael.
Okay, bye-bye.